The types of samples we will discuss all fall under the topic of probability samples. With the probability samples, N subjects are selected in such a way that each individual member of the population has a known, but not necessarily equal, chance of being selected. So the type of samples we will look at that fall under probability samples are these: random samples, simple random samples, systematic samples, stratified samples, and cluster samples. And all of these have two things in common. The first is that every member of the population has a known non-zero probability of being selected. So that's the case for all of these types of samples, that we could determine what their probability is, each member of the population is, of being selected. And that at some point in the process there's some random selection involved. The entire process may not be random, but there is some randomness involved at some point in the process. So let's first look at a random sample. Here, N subjects are selected in such a way that each member of the population has an equal chance of being selected. So in this case, it is equal. Now we said for a probability sample, it doesn't have to be equal. Random sample falls under there because in that case it is, but it's not necessarily so. So a different type of sample might not be equal. But for a random sample, every member of the population has an equal chance of being selected. A simple random sample now sounds similar, but let's look at the distinction. N subjects are selected in such a way that every sample of size N, every possible sample we could make of that sample size, has an equal chance of being selected. So that's not mentioned in random sample, that every possible sample we could form has an equal chance of being selected, just that each member of the population does. Now we'll be talking more about these two types of sampling in a future video, so I won't go any further with them right now. Systematic sample. We'll randomly choose a starting point, so there's that randomness that's part of the process, and then we select every kth subject in the population. So that number k has to be determined. So let's look at an example of that. Systematic sampling. So suppose you want to sample 8 houses from a street of 120 houses. So we could divide 120 by 8 and see that we get the number 15, and we'll use that as our k. So every 15th house is chosen after you randomly choose a starting point between 1 and 15. So in that first group of 15, you find your starting point. So say your starting point is 11, then you choose house number 11, and then you add 15 and go to house 26. And then you add 15 and go to house 41, etc. So the randomness is in where we start, but then after that, clearly once you've chosen house 11, house 22 is never going to be selected. House 35 will never be selected. So we lose the randomness there, but what we have is a system now of selection. Okay, let's look at the definition of the next type of sampling. Stratified. In a stratified sample, we subdivide the population into at least 2 different subgroups so that subjects within the same subgroup share characteristics. So maybe males and females, something like that. Then we draw a sample from each group. Let's look at an example of that. So this one involves a company where we have the staff subdivided into these groups. So we have 90 full-time males and 18 part-time males, 9 full-time females, and 63 part-time females. So say we want to get a sample of 40 of these employees, and we have divided them up into these subgroups, and the characteristic they share is they're either male full-time or male part-time or female full-time or female part-time. Okay, so those are we have 4 subgroups here with that common characteristic. Say they want to do a survey of these people, and if they just randomly chose from the number these employees, 40 people, they could get a heavy representation of full-time males, since there are 90 of them, or full-time or part-time females. And say they want a more representative sample, so what we'll do is figure out, well, then what percent of the employees are male full-time, male part-time, female full-time, female part-time. Well, the total number of employees we have here, we add this up, is 180. So, if 90 of them, 180 are male full-time, well then that's 50%. And 18 are male part-time, and that would be 10%. This is the percent male part-time. And the percent female full-time would be 9 out of 180, and that ends up being 5%. And 63 out of 180 ends up being 35%. And this should add up to 100% of our employees, because they all got categorized into one of these. Okay, so now, but we only want 40 in our sample, right? So now what we'll do is use those percentages to find out how many males should be sampled. Okay, 50% should be males. 50% of 40 is 20. 10% should be male part-time. 10% of 40 is 4. 5% of 40 is 2. And 35% of 40 is 14, and again this should add up to our 40 employees. So this is stratified. We break up the population into groups that have common characteristics, and then we sample from each one of those groups. We don't take all in the group, because ultimately that would just be sampling every single employee, and that would be the entire population. So what we're doing is taking some from each one of these groups. So we take 20 of those original 90 male full-time employees and 4 of those original 18. Okay. Let's look at our next type. Cluster. We divide the population into sections and then randomly select some of the sections and choose all members of those sections for the sample. So what's different here? Well, stratified, they have to have a common characteristic, and then we sample from each one of the groups. Now here we divide up into sections. They may be geographical or something like that, and typically they are. And then we randomly select within. So we don't take all. We do take all in this case. We didn't here. Remember, we just took 20 of those 90 males. Here, once we choose the section, we select all for the sample. So let's look at an example of this one. Okay, so suppose that the Department of Agriculture wants to investigate the use of pesticides by farmers in Tennessee. A cluster sample could be taken by identifying the different counties in Tennessee as clusters. Then a sample of these counties or clusters would be chosen at random. There's the randomness involved, so that all farmers in those counties selected would be included in the sample. See, all in the county. We don't take all counties, but once we randomly select the number of counties we want, we take all in the county. It can be seen here that it's easier to visit several farmers in the same county than to travel to each farm in a random sample. So if we just randomly chose farmers in the state of Tennessee, we might be driving all over the place, right? But here, if we select certain counties, then we're just driving all around one county, including each farmer in that county in our sample. So that's the difference between cluster and stratified. Okay, well, there is one other type of sample. Let's move this back up. That we see that is not one of these that we're looking at. We talked about random sample, simple random sample, systematic, stratified, cluster. They all have some randomness to it. Random sample and simple random sample are definitely random. And then these other three have some element of randomness. But we also see sometimes the results of studies that were done using convenience samples. And this is when the sample data is collected in the easiest way. And I'm showing it here in a different color because this is not a desirable way to collect a sample of data. And an example of that might be if students in a sociology class are asked to conduct a survey to learn more about a particular issue, such as the connection between certain beliefs about society and income, and the students just distribute the survey to their classmates because the members of the class are easy to access. They're going to get a high response rate because they're all helping each other with the project. But this one sociology class is most likely not representative of society at large. So, it was convenient. They get some results, but does that class represent the true population that they were interested in? Probably not. So we want to be aware that sometimes data is collected this way. If you stand at the front door of a department store as people come through, you're just sampling those that come through that particular door during the hours that you chose to stand there. That's convenient. It's not that you can't get good information, useful information, but it's not a true statistical study. So what we want to take from all of this is that we need to be able to recognize the types of sampling used in various studies. We want to avoid convenient sampling. And as we move into the data analysis portion of our course, we will only be using simple random samples, not these others. And you'll learn more about those in the simple random sample in another video.